For evidence of this are the old illustrations and prints and pictures of Old Father Thames, because during the hardest and toughest winters of that little ice age, the Thames would freeze over. And there were wonderful ice fairs held on the Thames, skating and people actually selling things on the ice.
If we look back further in time, before the Little Ice Age, we find a balmy golden era, when temperatures were higher than they are today, a time known to climatologists as the medieval warm period.
It's important that people know that climate enabled a quite different lifestyle in the medieval period. We have this view today that warming is going to have apocalyptic outcomes. In fact, wherever you describe this warm period, it appears to be associated with witches.
We're having a heat wave.
In Europe, this was the great age of the cathedral builders, a time when, according to Chaucer, vineyards flourished even in the north of England.
All over the city of London, there are little memories of the vineyards that grew in the medieval warm period. So this was a wonderfully rich time. And this little church, in a sense, symbolizes it, because it comes from a period of great wealth.
Going back in time further still, before the medieval warm period, we find more warm spells, including a very prolonged period during the Bronze Age, known to geologists as the Holocene maximum, when temperatures were significantly higher than they are now for more than 3 millennia.
If we go back 8,000 years in the Holocene period, our current interglacial, it was much warmer than it is today. Now the polar bears obviously survived that period. They're with us today. They are very adaptable, and these warm periods in the past, what we call hypsithermals, pose no problem for them.
Climate variation in the past is clearly natural. So why do we think it's any different today? In the current alarm about global warming, the culprit is industrial society. Thanks to modern industry, luxuries once enjoyed exclusively by the rich are now available in abundance to ordinary people. Novel technologies have made life easier and richer. Modern transport and communications have made the world seem less foreign and distant. Industrial progress has changed our lives. But has it also changed the climate? According to the theory of man-made global warming, industrial growth should cause the temperature to rise. But does it?
Anyone who goes around and says that carbon dioxide is responsible for most of the warming of the 20th century hasn't looked at the basic numbers.
Industrial production in the early decades of the 20th century was still in its infancy, restricted to only a few countries, handicapped by war and economic depression. After the Second World War, things changed. Consumer goods like refrigerators and washing machines and TVs and cars began to be mass-produced for an international market. Historians call this global explosion of industrial activity the post-war economic boom. So how does the industrial story compare with the temperature record? Since the mid-19th century, the Earth's temperature has risen by just over ½ degree Celsius. But this warming began long before cars and planes were even invented. What's more, most of the rise in temperature occurred before 1940, during a period when industrial production was relatively insignificant. After the Second World War, during the post-war economic boom, temperatures, in theory, should have shot up. But they didn't. They fell. Not for 1 or 2 years, but for 4 decades. In fact, paradoxically, it wasn't until the world economic recession in the 1970s that they stopped falling.
CO2 began to increase exponentially in about 1940, but the temperature actually began to decrease 1940, continued till about 1975. So this is the opposite relation. When the CO2 is increasing rapidly, but yet the temperature is decreasing, then we cannot say that CO2 and the temperature go together.
temperature went up significantly up to 1940, when human production of CO2 was relatively low. And then in the post-war years, when industry and the whole economies of the world really got going, and human production of CO2 just soared, the global temperature was going down. In other words, the facts didn't fit the theory.
Just at a time when, after the Second World War, industry was booming, carbon dioxide was increasing, and yet the Earth was getting cooler and starting off scares of a coming ice age, it made absolutely no sense. It still doesn't make sense.
Why do we suppose that carbon dioxide is responsible for our changing climate? CO2 forms only a very small part of the Earth's atmosphere. In fact, we measure changes in the level of atmospheric CO2 in tens of parts per million.
If you take CO2 as a percentage of all the gases in the atmosphere, the oxygen, the nitrogen, and argon, and so on, it's 0.054%. It's an incredibly small portion. And then, of course, you've got to take that portion that supposedly humans are adding, which is the focus of all the concern, and it gets even smaller.
Although CO2 is a greenhouse gas, greenhouse gases themselves only form a small part of the atmosphere. What's more, CO2 is a relatively minor greenhouse gas.
The atmosphere is made up of a multitude of gases. A small percentage of them we call greenhouse gases, and of that very small percentage of greenhouse gases, 95% of it is water vapor. It's the most important greenhouse gas.
Water vapor is a greenhouse gas, by far the most important greenhouse gas.
So is there any way of checking whether the recent warming was due to an increase in greenhouse gas? There is only one way to tell, and that is to look up in the sky, or a part of the sky known to scientists as the troposphere.
If it's greenhouse warming, you get more warming in the middle of the troposphere, the first 10-12 kilometers of the atmosphere, than you do at the surface. There are good theoretical reasons for that, having to do with how the greenhouse works.
The greenhouse effect works like this. The sun sends its heat down to Earth. If it weren't for greenhouse gases, this solar radiation would bounce back into space, leaving the planet cold and uninhabitable. Greenhouse gas traps the escaping heat in the Earth's troposphere, a few miles above the surface. And it's here, according to the climate models, that the rate of warming should be highest, if it's greenhouse gas that's causing it.
All the models, every one of them, calculates that the warming should be faster as you go up from the surface into the atmosphere. And in fact, the maximum warming over the equator should take place at an altitude of about 10 kilometers.
A scientist largely responsible for measuring the temperature in the Earth's atmosphere is Professor John Christie. In 1991, he was awarded NASA's Medal for Exceptional Scientific Achievement, and in 1996 received a special award from the American Meteorological Society for fundamentally advancing our ability to monitor climate. He was a lead author on the UN's Intergovernmental Panel on Climate Change, or IPCC. There are two ways to take the temperature in the Earth's atmosphere: satellites and weather balloons.
What we found consistently is that in a great part of the planet, that the bulk of the atmosphere is not warming as much as we see at the surface in this region. And that's a real head scratcher for us, because the theory is pretty straightforward. And the theory says that if the surface warms, the upper atmosphere should warm rapidly. The rise in temperature of that part of the atmosphere is not very dramatic at all, and really does not match the theory that climate models are expressing at this point.
One of the problems that is plaguing the models is that they predict that as you go up through the atmosphere, except in the polar regions, that the rate of warming increases. And it's quite clear from two data sets, not just satellite data, which everybody talks about, but from weather balloon data, that you don't see that effect. In fact, it looks like the surface temperatures are warming slightly more than the upper air temperatures. That's a big difference.
That data